Welcome back. We're going to talk about circuits and circuit diagrams in specific for a little bit. But if you remember what we were doing last week, we started talking about a charge, but it was in place. So we had electrons just having a static discharge or something of that nature. Okay? But now what we're going to do is what happens if circuits are allowed to flow. Okay? So first off, what's a circuit? What are we going to be looking at? And a circuit is just a closed, continuous path through which current flows. Current is just the flow of electrons. Okay? So it has to be a closed path in some way, shape, or form. And we're going to have two different types that we're going to look at. But, basically it has to be closed. It can be a circle, it'll be a square, it can be all kinds of things, right? But it has to be a closed path. It has to come back to where it starts in some way, shape, or form. We need a voltage source, like a battery or electricity, and we're going to talk about this idea of potential difference as well. But you have to have something that initiates that flow of electrons. Okay? When we draw our diagrams, there's 4 or 5 general things we're always going to use, so we're consistent. You have a wire, just a straight line. A resistor is a squiggly line. You'll see me, when I start doing that, I'm just talking about a resistor. If you're talking about a specific type of resistor as a light bulb, you'll use this sign. Batteries, short ones, long ones, short ones, okay? And then a switch. A switch basically opens and closes that circuit, okay? We'll have some of those, and we'll be able to draw these. When we talk about something called a series circuit, we're talking about a single pathway, one pathway for those electrons to move. It's coming off the battery, going that way, going to that lamp, going to that lamp, and then heading for home. Okay? Going that way. One pathway. Okay? If you want to do the diagram, it's doing this. Okay? Remember, things flow positive to negative. Remember, it's positive because it's giving up is negative. In a series circuit, that amount of current is the same through each device. Current is an I, by the way. It's measured in amps. Okay, so the current is the same throughout each device. The resistance is the sum of all the individual resistors. Okay, and we'll be a little bit more specific about that, but if you go back to the other diagram, right, this lamp has a little bit of a resistance to it, this lamp has a little bit of a resistance to it. Okay, and a resistor is just simply that impedes the flow of the current. Okay, so basically anything you put in the way in that circuit is going to be a resistor. We just happen to use lamps. That voltage drop, V, across each device depends on that resistance. Okay? The total voltage divides among the individual electric devices. And I'll show you how that works in a little bit. But, when we come down to the math, you're going to come into this equation here, V equals IR, where voltage is current times resistance. And we'll show you how all this fits together when we start summing some things up. Okay, so you have a voltage drop across each resistor. That voltage divides itself between every lamp or whatever it is that's in that series. When we go to a parallel circuit, we can have branches. What does that mean? That means we can have more than one way through the circuit. So if we started here, there's a fork in the road, I can go to that bulb, or I can go to that bulb, okay? And then you come make your way around, right? So here, one branch goes to 2 branches. Here, 2 branches goes to 1 branch, okay? You can also think about it, I'm going to go back just a sec. If you look at these bulbs here, kind of like my old school Christmas lights, if one of these bulbs goes out, what do the other ones do? Think about that. if one of these bulbs breaks, what do the other ones do? And then compare that to this parallel circuit, where if one of these bulbs goes out, what does the other one do? Okay? In a parallel circuit, the total current is the sum of all the currents in the branches. Okay? So, and also, as you increase the number of branches, the overall resistance is decreased. Voltage is constant for each resistor. Okay? We're going to put together a little data table for you at the end on all of these details that makes things really, really clear. Combining resistors. What happens if you have more than one or two? Okay? Well, in a series circuit, the resistance, the equivalent resistance or the total resistance is simply you add them up. First one plus the second one plus the third one. Okay? So series resistors, you just keep adding up. In a parallel circuit rather, you end up with this equation where you have the inverse of the total resistance equals the inverse of the first one plus the inverse of the second one. Okay? So in series, just add them up. In parallel, take the inverses. And we'll show you the math in just a sec too. Summary. This is the page you need to remember right here. These are the fundamentals. You have a series circuit, you have a parallel circuit. In a series circuit, the voltage equals current times resistance. In a parallel circuit, this is constant. The current is constant in series. The V equals IR for each resistor here. And then how do we figure the resistance? We add them up. We take the inverses. Okay? This is the most important sheet right here. You have to remember these fundamentals. The fundamental formula we're looking at is simply V equals IR and all of its differences, right? If you solve for I, what do you get? V over R. Okay? Here's an example. And again, the thing that we want to be able to describe each circuit is what's the voltage, what's the current, what's the resistance. Well, here's my voltage right here, right? I got a 9-volt battery. I got 2 resistors. Okay? Things you got to think about. What's my voltage? What's my current? What's my resistance? Well, you can do the resistance easy. What did you have to do? Well, here's some answers for you. The resistance is simply 3 plus 2 equals 5 ohms. You know the current is the same throughout all the branches, so take your 9 volts from your battery. Remember, V still equals IR. Okay? Okay? So get your current right there. Your 9-volt battery. Your equivalent resistance is 5, so the current throughout the whole thing is 1.8 amps. Okay? To get the voltage, you take your 1.8 amps, you got through 2 ohms, and you got through 3 ohms. So you can get that voltage drop across each one. Make sense? Find the resistance. For a series circuit, find the resistance, find the current, find the voltage. So for a series circuit, you just add the resistors. The current is the same throughout each one, and the voltage drops across each resistor. Here's one. Here's your second example. Right? There's your resistance, current, voltage. Okay? Well, what's your total resistance? 5 plus 4 plus 3. How many is that? Your resistance equals 12 ohms. What about your current? Okay, well, your current is, remember, if your equation is V equals IR, then I equals what? V over R, okay? So your I would be what? 15 divided by 12. Okay? And then take this number and solve here for your voltage drop across each resistor. Does that make sense? Find your resistance, find your current, calculate your voltage. What about for a parallel circuit? Okay, again, everything, we still need R, we still need I, and we still need V. That's what we're looking for. Here's, we're coming off a 9-volt battery. We got two different pathways. Okay? What's going to happen? Well, your equivalent resistance is 1/2, 1 over R, the total, 1 over 2 plus 1 over 3. You can find a common denominator, just get some decimals. Okay? You know the current is different throughout each one. And then the voltage is the same as when you started. Okay? V equals IR, so I equals what? V divided by R. Well, you got a 9-volt battery. There's your resistance. That gets you current. Okay? Makes sense? Find your resistance. Find your current. Find your voltage. Okay? There's another example. If you have 3, I'll keep this up here for a bit just so you can watch it. You got a 15-volt battery, right? You have 3 branches. You got a 5-ohm branch and a 4-ohm branch and a 3-ohm branch. Okay? You know your voltage is 15 volts. Your resistance equivalent is 1 over 5 plus 1 over 4 plus 1 over 3. Okay? Remember, when you solve these, I don't want to know what 1 over R equals. I want to know what R equals. So you have to take the inverse of that when you get to the end, right? And then find your current each way, too. Does that make sense? Find your resistance, find your current, find your voltage. Each has its own little quirks. Okay? Each has its own little quirks. That's why I'm going to go back to this other page here. This page right here. This is what you need to commit to memory. Series circuit. Voltage drops, current is constant, resistance is added. Parallel circuits. Voltage is constant, current changes, and you use the inverses of your resistance. This is the most important slide on this puppy. Okay, we'll see you in class. Happy trails.